And a lot of it is review from, or not review, but it's similar concepts to stuff that we've learned in algebra, right? Yeah, the main thing is just to, on an interval, right, we know that the absolute maximum is the highest y value and the absolute minimum is the lowest y value. These are all just kind of, I just took these from the textbook. I would really recommend like reading through the section, but these are just like the theorems and definitions from all the sections. Not all of them are used on the exam. I think you need to read all this stuff, especially this definition of an interior point. An interior point of the domain is a function of f, is function f, where f prime is 0 or undefined is a critical point. So that's basically telling us that to find our critical points, we're going to set the derivative of our function equal to 0, and then we're also going to look at it and say, okay, where is this function not defined? Because that's going to be a critical point. And we use these critical points to find our absolute mins and maxes in an interval. I see a couple more people have joined. Here's the attendance link. And then for mean value, for 4.2, for mean value theorem, you really just need to know this equation. You need to know this equation will get you the slope of the secant line, and then that slope is also equal to your f prime of c, c being some point between a and b. And that's about it. And these are just kind of some graphs to illustrate. I don't think he uses Rolle's theorem on the exam, but all Rolle's theorem is stating is that where f prime of some number equals 0, that's going to be a critical point, or there's going to be at least one derivative at c that equals 0 between a and b. All right. So the first function, or first problem, is going to be kind of a warm-up, kind of an easy get your brain starting. This is just a graphical function. We're not given the function itself, but it's asking us to find the extreme values of the graphical function y equals h of x. So this is where a is, c1, c2, and b. So just drawing these little lines to it, we can see where those points are. Now, just looking at this, from what you know about local mins and local maxes, what would be, or not local mins, absolute mins and absolute maxes, what would be the absolute maximum value for this problem? Right? It's not a set value, but how could we write that? B? Yeah. X is equal to B is our absolute maximum. Or you can write it as, well, I would write both. I would write x equals b as the absolute maximum, but you can also write it as y is equal to h of b, right? So I would write both. And then what about our local minimum? What's the lowest y value of this function? Yeah, exactly. It's going to be c2, right? So x equals c2, or y equals h of c2 is going to be our absolute minimum. All right, that was awesome, guys. Yeah, so just to reiterate, for your absolute minimum, you're looking for the lowest y value on that interval, including the endpoints, and you're also looking for the highest y value in that function, including the endpoints. And you notice that in this case, our endpoint is one of the absolute maximums, or it is the absolute maximum. So whenever we're doing our problems, we have to check our endpoints as well, including the critical points. So for our next problem, we're going to do some stuff algebraically, right? For the next problem, I took out of the back of the section of 4.1. It's not question 1, it's question 29. The one up here is just a picture from question 1 in 4.1. But for problem 29, they want us to first, part A, let me write the function first. Our function is g of x is equal to root 4 minus x squared. And they want us to A, find critical points. I have it a little more nicely written on my sheet, but find critical points is our first part of the problem. And our part B is we want to find our absolute min slash max. So it's kind of, and this is similar, like you'll see this part, he'll give you one equation on the exam. This question will be 8.1 and this question will be 8.2. So that's how it's going to kind of correspond in the next two problems I do. So for part A, to find critical points, we first need to take the function's derivative, right? Because we know where a critical point is, its derivative will equal to 0 or the derivative will be undefined, right? So, right, our function's g of x. That means we just have to find g prime of x, which we should all be pretty good at doing now, hopefully. Right, so let's just write g prime of x, or let's write g of x. We know that's 4 minus x squared. And then we can just, like we do before we take derivatives, we can just write that as a 1/2 power. That square root as a 1/2 power. Right? So what's the first step when we take the derivative of g of x? Yeah, power rule. Exactly. So we're going to bring down that 1/2 power, subtract 1 from the exponent to get what? What's our exponent for this? Yeah, negative 1/2. And then we have to multiply it by what on the inside? Yeah, exactly, Sophie. We're going to multiply by the inside. So it's going to be d dx 4 minus x squared. Right, so now we just have to take the derivative of 4 minus x squared. Right. So what's the derivative of our of 4 minus x squared? Yeah, negative 2. So we're going to have negative 2, and we still have this 2 in the denominator, and I'm going to rewrite that negative 1/2 power as a square root and bring it down to the denominator, so we get 4 minus x squared in the denominator under that radical. We see that those 2's are going to cancel out, and so we get negative x over root 4 minus x squared. All right. So this is our g prime of x. All right, so that's our step 1, is to just find the derivative. Our step 2 is we need to look at our g prime of x, right? And we need to figure out what value makes g prime of x 0, and also what values makes g prime of x undefined. Right? What makes a function undefined? What's something that we see very often that makes a function undefined? Something we've looked out for in the previous, yes, exactly, 0 in the denominator. Right, what value would make our denominator 0? Yeah, 2. And there's another value, right? There's 2 and, yeah, and -2, right? So we know that x equals 2 and x equals -2 are going to be critical points, because g prime of x is undefined there, right? But we still have to do one more step, right? And we have to find g prime of x when it's equal to 0, right? So we're going to set g prime of x equal to 0. G prime of x equals -x over root 4 minus x squared equals 0. We can multiply both sides by that denominator to get rid of that denominator. So we get -x equals 0. Simple enough, right? And then if we just multiply both sides by -1, we get x equals 0. So those are all of our critical points. I'm just going to write critical. Does that make sense why these are our critical points? Where did the bottom go? We multiplied both sides by 4 minus x squared, by root 4 minus x squared, my bad, to get it to cancel out. And anything times 0 is 0, right? How do we get the critical point again? So a critical point is any point where g prime of x is undefined, or where g prime of x is equal to 0. So we looked at our original function and said, okay, where is g prime of x undefined? So we know a function's undefined when we divide by 0. We say, oh, if we plug in 2 or -2 for x, then we know that we'll be dividing by 0 and the function will be undefined. So we know those are critical points. And then from there, we still have to set our function equal to 0. We do some simplification, and then we get x equal to 0. So these are all critical points. I know in his work he denotes it x sub c, so I guess I'll just keep that consistent, just to note that these are all critical points. Right, and that's our final answer for part A, right? Just find the critical points. So this is very similar to what we would do on 8.1 or 8.3 on the exam. So our critical points for g of x on, I don't think I specified the interval earlier, but the interval is supposed to be -2 to +1. I'm sorry. That doesn't really come into play until part B. Yeah, this is the problem, just 29 right there. Yeah, no problem. Yeah. So critical points for g of x on -2, 1 are xc is equal to 0, xc equals -2, and then xc equals +2. Okay, any questions on part A for this problem? We know 2 and -2 are critical points because if we plug them into the denominator will equal 0, right? So if we plug in 2 for x, right, we get -2 over root 4 minus 2 squared, and then we get 4 minus 4 in the denominator, which is 0. We can't divide 2 by 0, right? 2 divided by root 0 equals 2 divided by root 0, which is undefined. And same thing if you plug in -2, you'll get the same answer, because any number squared is positive. Yeah, I mean, you can set it equal to 0, but like, you could do the reverse of what we did here. Multiply both sides by x, or by 1 over x, right, in this part. And then raise everything to the -2 power, and then you would get 4 minus x squared equals 0. And you get 4 is equal to x squared. If you take root of both sides, you get x equal plus minus 2. Can we put any other number besides that 2? Yeah, the -2. As any number squared is going to be positive. So 2 and -2 both work as our undefined points. But Elahor, yeah, that's another way. If you don't think of how to of like, oh, where is this function undefined, you can algebraically solve for it. You just have to do kind of this step twice. Yeah, and I was about to get to that, Abby. It's not XE, it's XC. It stands for critical point. It's the critical point of X, if that makes sense. Yeah. All right. Yes. Let me see what he words it on the actual exam. Because I know it does affect the answer for part B, but it's just not a critical point on that interval. Because the function continues outside that interval, it's just we're only looking at that one interval. Hold on, I'm about to pull it up. So he says, yeah, all right, so if this was the exam, we wouldn't include that 2, right? Because it's not included in this interval, right? Yeah, good catch. But in general, those are the 3 critical points. It's just since 2 isn't included in -1 or -2 to 1, positive 2 is not included. Thanks for that question, Nathan. That was a good one. All right. And then for part B, we are going to use these. We're going to use these critical points in order to find out which one is our maximum and minimum. So we're going to make a table, actually. So for part B, to find absolute min / max. I think a couple people more joined, so I'm going to send my attendance link one more time. Please sign in, that'd be fantastic. And so to find the absolute minimum and maximum for this problem, well, the first thing I was going to do is we have to look at which points are in the interval, but since we just did that at the end of last problem, which I guess I should have included, but I can fix that on my answer key. You have to make sure that your critical points are actually included in the interval, and then we also have to evaluate the endpoints. So we see that -2 is already one of our critical points, and it's an endpoint. 0 is inside that interval, but we don't have 1. So we also need to evaluate this function at 1. Can you guys hear me okay? Do I need to switch mics? I have another mic. You can hear me okay? Okay. All right. All right. Yeah, so our first step is to just we're going to create a table of all these points of xc equals -2, 0, and x equals 1. Yeah, and thank you for typing that, Abby. I appreciate that. So we're going to make a table. So one side's going to be our critical points. And the other side is going to be our g of x, our function. On this step, we found our critical points using the derivative, but we're evaluating our original function at these derivative points, if that makes sense. So in this step, we're not even dealing with our derivative anymore. So we have xc equals -2. All right, so let's start with that one. We know g of x is equal to √4 minus x squared. So we're going to plug in -2 for that. G of -2 is going to equal to √4 minus -2 squared, right? That's just going to equal √4 minus 4, which is going to equal √0, which is going to equal 0. Right? So that's our first one. And then we have xc is equal to 0. Right? So what would that function evaluated at 0 be? Yeah, because it's just 4 minus 0 under the square root of 4 is 2. All right, so that's our second point. And then what about xc at 1? So we have g of 1. So we're going to have 4 minus 1 under the radical. It's going to be √3. So that's our third point. All right, so now we've evaluated all the critical points. We want to find the maximum and minimum y value. This row right here these are our y values. So you're going to look at that right side of the table and say, which is my lowest value and which is my highest value. And your highest value is going to be your absolute maximum, and your lowest value is going to be your absolute minimum. So if I'm looking at this table, which one is our absolute minimum?
The 0. Let's see.
Yeah, 0. Yeah. And then what about our absolute maximum? Yeah, our maximum is 2. The critical point 1 came from the endpoints. We also, whenever we look for see what's our absolute minimum and maximum, we also want to check our endpoints. It's just because a lot of times one of our endpoints ends up being a critical point, so it's just good to check them. So I guess for writing our answer, we would say the absolute min on the interval -2, 1 is y min is equal to 0 at x equals -2, and then the absolute, let's shorten this, absolute max on -2, 1 is y max is equal to 2 at x equals 0. So that's how we would write that. Do we always check the endpoints for every problem, or only sometimes? You need to check the endpoints. That's just part of the process for finding absolute mins and maximum over a given interval, that is. If it's not a given interval, then you look at the whole function, right? But a lot of times when you look at your whole function, you just have local mins and maxes, which is why we're dealing with intervals. All right. I'm really glad we're getting into, at least for you guys, I'm glad that we're getting into a little bit easier material than test 5 and 6. I think these last two tests aren't nearly as bad in terms of their difficulty. I hope you all feel the same way. For this next problem, we're going to do the exact same thing. Yeah, it was, I think if you really studied this last test, you should have done well on it, at least hopefully. The last two exams, if the material hasn't quite sat in your brain yet, then it definitely could have been difficult. So we're going to do the exact same thing for this problem over that function. We need to find the critical points for part A, and then for part B, we need to find absolute min and max. For critical points, like I said before, we take the derivative of the function, and then we evaluate that function at 0, and we look for parts of the function where it's undefined. So this should be a slam dunk for you guys. What's our derivative of sine? Yeah, exactly. It's going to be cosine. So our f prime of theta is going to be cosine theta. Is there any point in the function cosine theta that it's going to be undefined? It's not a trick question, I promise. Think of what the cosine function looks like. Is it undefined anywhere? Yeah, it's that you can't, we're not dividing by 0. There's no bounds for it. So yeah, it's defined everywhere, so we don't have to worry about that for cosine. And then for our next part, we have to check where cosine theta equals 0, right? So we're going to set cosine theta equal to 0. Right. Now, do any of you guys remember how to find theta in this situation? Like, how would we solve for theta, right? Because we need to evaluate our function at 0. So we need to find where our variable is equal when the function is equal to 0. Unit circle, yeah. So how do we, there's something that we can do to get that theta by itself on one side of the equation, right? What's the opposite of cosine? Not like reciprocal, but what is the opposite? Secant, not derivatives, but 1 over secant. We're kind of going, trying to think of a way to, yeah, your arc cosine, inverse sine. Those will give you the opposite values on your unit circle, right? They're going to give you like the pi values on your unit circle rather than your cosine point in the unit circle, right? So cosine theta equals 0 can turn into theta is equal to arc cosine of 0. Right? And then if you think back in your unit circle, what values of pi is cosine equal to 0? So in this step, we're asking what values of pi equal, or what values of cosine equal 0? Yeah, pi over 2, negative pi over 2. Yeah, those are both good ones. 0, Not 0. Do you know why it's not 0? Or I think you have your unit circle backwards, Nathan. Where is cosine equal to 0? When at cosine of 0 equals 1, correct? So our cosine of 1 would equal 0. I think you're looking at the wrong axes, Nathan. Yeah, it's, can I show you how I got that? Yeah. I'm actually just gonna pull up a picture of the unit circle. You give me like 2 seconds. Right. So we know at 0, cosine is equal to 1, and sine is equal to 0, right? Because it goes cosine, sine. So the arc cosine of 0 is going to equal pi over 2, right? Also, the arc cosine of 0 is going to equal 3 pi over 2. It has more than, your arc cosines and your arc sines are going to always have more than one value. So it's going to equal pi over 2, negative pi over 2, 3 pi over 2, and negative 3 pi over 2. So that's how I got those values. If you're still a little confused on it, I'd be happy to help you on this on Wednesday during office hours. Otherwise, I really suggest you look at your unit circle, because I think I told you guys during our algebra review to really just know your unit circle. If you still haven't memorized it, you really need to, especially if you are going on to Calculus 2. Alright, so now we've stated that theta can either equal plus or minus pi over 2, or plus or minus 3 pi over 2, right? But our interval was negative pi over 2 to 5 pi over 6, right? So that means that 3 pi over 2 is not included in that interval. Plus and minus 3 pi over 2 is not included in that interval. So that means our critical points of theta are positive pi over 2 and then negative pi over 2. Any other questions on this one? I picked this one not because I picked this one because it's a trig, and I feel like some of y'all might have forgotten how to find the values this way. And then from here, after finding the critical points, we can just go on to finding our absolute min and max, right? So we see that negative pi over 2 is one of our endpoints. We also have pi over 2. 5 pi over 6 is not one of our is not one of our critical points, but we still need to evaluate it because it's our endpoint. All right, so we're going to make that table like we made earlier. So we're going to have critical points. And then we're going to have our function, I think it was f of theta. And f of theta is equal to sine theta, right? Because we're plugging it into our original function, not our derivative. So let's start with negative pi over 2 for our first one, for our first point. So if we plug in negative pi over 2 in our function, what do we get? What's the value of sine of negative pi over 2?
Is
Yeah,
1,
it's just going to be -1.
okay.
Alright, and then what about positive pi over 2? We have f of positive pi over 2. Yeah, exactly, it's going to be +1. Right? And then we have our 5 pi over 6, right? Sorry. For 5 pi over 6, right? We have f of 5 pi over 6 is equal to sine 5 pi over 6. Well, do any of y'all remember the value of sine 5 pi over 6? Yeah, it's just 1/2. Exactly. Alright, so now looking at this side of the table, right, the right side of the table, what's going to be our lowest value? Yeah, -1. And then our largest value. Yeah, 1. Right, so those are going to be our absolute min and maxes, right? So I'm not going to write that whole statement out like last time. I'm going to just write absolute min is y min equal to -1 at x equals negative pi over 2. And then our absolute max, y max, equals +1 at x equals pi over 2. And if you think about this, this really makes a whole lot of sense, right? Because our sine function just looks something like this. That's a terrible sine function, but it just looks something like that, right? And it's bounded between +1 and -1, right? So it makes a lot of sense why those are our, when we're looking between two different intervals, right? Whatever it's going to be, something like that is going to be our interval. It makes a lot of sense why those are our absolute max and absolute minimum. And if you want to see like graphically, like I encourage you guys to like graph using Desmos and stuff like that. Any other questions on this part or the previous part of this problem? Awesome. I know we've been kind of doing the same thing for both problems, but we're about to do it again with 8.1 on the exam. And then after, if we still have time after doing 8.1 and 8.2 on the practice exam, I have another problem that involves section 4.2. Because so far we've really just been covering, chapter 4.1. Yeah, I agree. More practice is better, for sure. So for 8.1, they want us to find the critical numbers, right, of the function on the interval. Right, so our function for this one is 1/3 x cubed minus x squared minus 3x plus 4. Right, and then it's on the interval -2, 6. Right. So when finding critical points, like we've done before, what's the first thing we do? Yep, exactly. We take the derivative of the function, right? So step 1, we take its derivative, right? F of x equals 1/3 x cubed minus x squared minus 3x plus 4. F prime of x. This you guys should be able to do. So what's the derivative of this function going to be? It shouldn't be too complicated. x squared minus 2x minus 3. Yeah, exactly. X squared minus 2x minus 3. Good job. And then from there, we have to evaluate where is f prime of x undefined slash f prime of x equal to 0. Alright, so if we're looking at this function, and it's not a trick question, I promise you. If we're looking at this function, where would it be undefined, if anywhere? Zero? So it's defined everywhere. A lot of times we get so our derivative can equal to 0. That's totally fine. I think you might be. I think Amon might be going ahead a tiny bit, maybe. But yeah, so it's defined everywhere, and pretty much all like regular polynomials that look like this, right, are going to be defined everywhere, right? If you get a derivative like this and it looks like something like x cubed plus x squared plus x, like that's going to be defined everywhere. You're not going to run into an issue there with where the function is defined. But if you start getting like you're dividing by stuff or it's inside like a natural log or something, that's when you kind of need to look out. So since it's defined everywhere, we can just go in and set this function equal to 0, right? That's our next step. So we have x squared minus 2x minus 3 equals 0. And this is just a simple factoring problem, right? So what would this statement factor into? I mean, you can use the quadratic formula if you like, but I find factoring easier. Yep, it'd be x minus 3 times x plus 1. And that's going to be equal to 0. And you know, whenever we have two things being multiplied that's equal to 0, we can set both of these things individually equal to 0. So that means that x minus 3 equals 0 and x plus 1 equals 0. So we're going to get x is equal to 3, and then x is equal to negative 1. So these are going to be the critical points of that function. And that's our final answer for 8.1. So not too bad, right? I hope so, at least. Any questions on this one? Will he give us the undefined ones? There probably will be one function that is undefined at some point on the exam, probably. For those functions, you really just have to, the main thing is just looking out for division by 0. Do you think he'll incorporate trig stuff? It's possible. It's always a possibility with Dr. Knowing that he's going to include trig stuff, because I mean, realistically, y'all should know your unit circle values. And trust me, you will know them like the back of your hand whenever you get into Calc 2, because they become like kind of a crucial player. But I would prepare for at least like I would prepare like the simple trig ones like sine, cosine, maybe tangent. Yeah, so I would know those values for sure. And I mean, I've talked about how you can double check yourself on the calculator too, to make sure you're correct. So if anyone needs like a refresher on that, I can always go over that with y'all later. And so for 8.2, it's just kind of, I like to think of it as an extension of 8.1 because you have to solve 8.1 in order to find the answer for 8.2. And it's going to be like that for 8.3 and 8.4. You need to solve 8.3 before you can do 8.4. So for 8.2, they want us to find the absolute min and max of that function. And the interval was -2, 6. I'm just going to rewrite it. And the function was 1/3 x cubed minus x squared minus 3x plus 4. Alright, so neither of our critical points were the endpoints, so we do have to include these endpoints when we evaluate everything. So like before, we're going to make our table, right? If you have another way you like to do this, like in bullet points or something, then that's totally fine. This is just the way that works best for me. And if you have another way, I encourage you to share it, a different method of writing it. You can always share stuff like that. Right, so we have -1, 3, -2, and 6. All right, so let's start with -2. So now we're evaluating f of -2. And this stuff you can literally just plug straight into your calculator when you evaluate the function. So we're going to have 3 times -2 plus 4. All right. So simplifying that, we just get -8/3 minus 4 plus 6 plus 4. So it's going to be 6 minus 8/3, which is going to equal 10/3. All right, so now let's do -1. The -1 value is right up there. So evaluating that function at -1, we do the same thing. And then -1 cubed times 1/3 minus -1 squared minus -3 times -1 plus 4. So we get -1/3 plus 1 plus 3 plus 4. Or is it minus? No. Sorry, that should be a -1, because -1 squared is +1, and it's minus +1. So that should be -1/3 minus 1 plus 3 plus 4, which will equal 17/3, I believe. Yeah, I think I made that same mistake when I was initially doing this problem too, and I had to come back and be like, wait, and double check myself. So that's not the first time I've even done that today. And then we just have to check 2 more points, and that's going to be +3 and +6. Right, so for +3, really, you guys should be able to do this part. It's just plug and chug. So it'd be 1/3 times 3 cubed minus 3 cubed minus 3 times 3 plus 4, which is going to equal 27 divided by 3 is 9 minus 9 minus 9 plus 4 is going to equal -5. And then we have one more, and we're doing +6. So we have f of 6, 1/3 6 cubed minus 6 squared minus 3 times 6 plus 4, and I'm not going to bother writing this out because most y'all will just shove that in your calculator, and you'll end up getting 22 for this one. Right. Any questions on any of these? All right, so now we just have to look at the right side of the table and say, okay, what is our smallest y value? Which of those 4 values is the smallest? Yeah, -5, right? And then what about which one is the largest? 22. Yeah, that's absolutely right. So we're going to have -5 is our absolute minimum and 22 is our absolute maximum. And if you notice this time, one of our endpoints was actually the maximum, not one of our critical points, which is why it's important to check our endpoints as well. Does that make sense? Sometimes the function will just continue forever and will be higher than one of those. Yeah, I should have pulled up like a visual example, but yeah, it's because we're looking over that interval. If the interval was shorter, then maybe one of our other points would have been the absolute maximum. But now, so to kind of end this problem, we have y max is going to be equal to 22 at x equals 6, and then y min equals -5 at x equals 3. I'm just going to write abs max and then absolute min. And that's our final answer for that problem. Any questions on this one? Or any of the problems? We've kind of done the same thing over and over again today, but hopefully that'll help because that's like 4 of the 6 problems on the exam are just what we did today. So like 3.4 and 8.3 and 8.4 are written the exact same way as 8.1 and 8.2. The next problem, and we should have time for it, I'm going to do a mean value theorem problem, which will be similar to 8.5. The only one we wouldn't have like at least touched on would be 8.6, which I will definitely cover 8.6 on Thursday. Instead of writing abs max and abs min as complete sentence on the test, would it be okay to write them the way you just did? I would ask Dr. Noring personally for that question. I don't think he would give points off for writing it like this, but it is like a little more like professional and like a little clean cut if you write it in complete sentences as like a conclusion. But it should be fine. But if you want to just ask him, because I mean he'll be able to be like, oh, this was the max, this was the minimum. Maybe just write like instead of just writing abs max and abs min, you can just write like full like absolute max and absolute min and do like a colon and then write this stuff. I think that would be better. Does that make sense? But I guess you wouldn't have to write the full sentence. I don't think he would count off for that. But if you want to be sure, because I don't want to be the reason you get points off, I would ask him personally. And then actually, I don't know if we'll have enough time to cover this last problem, but we'll do this problem on Thursday. But the general process, I can at least like write out like the general process of what you're going to be doing for these problems. you're going to use the secant slope, right? Let me go back up here. You're going to use this highlighted function, right? This function right here is your secant slope, right? So you're going to find your secant slope, and there's going to be some values. Let's just say it's like 1 and 6, right? If you want to find the secant slope, then you would just plug in those values for your function, whatever your function is, and then you would plug in these values in the denominator. So your b would equal 6 and your a would equal 1. So you would have f of 6 minus f of 1 over 6 minus 1. You would solve for that. And then after that, you would take the derivative and you would set the derivative equal to this value to solve for c. As far as online, there's no memorization. I'm going to ask him about that tomorrow when I see him. But you like have to know this problem in order to do problem 8.5. This problem is a lot more algebra than calc, and you'll find that calculus is really just algebra with extra steps. And then when you get to calculus 2, you'll be like, oh, this is algebra and a lot of trig with extra steps. So it just, the more you do it, the more you're just like, oh, this is how it actually is. And it seems really complicated, but you'll get it a lot more the more problems you do. It's a lot more mechanical, this exam. Yeah, I'm sorry I don't really have time to go over that problem. I just think it would take maybe 10 minutes. Yeah, I hope all that helped. If you have any questions, I'm still going to be here, but I don't have anything else to cover. Yeah, you too, Doug. Have a great night. Have a great night, Sophie. No problem. Yeah, you too, Caitlin. Have a great night. No problem, everyone. Thanks for coming. I appreciate it. If you have any